All right, so we need to tell whether the graph is restricted or not restricted. Now let's remember that domain, when you're looking at a graph, you're going to think about whether the graph is, how the graph is moving left and right. And for the range, you're going to think about how it's moving up and down. So number one is a parabola, and it moves sort of diagonal to the left forever, diagonal to the right forever. And so I'm going to say for number one that the domain is not restricted. The range, however, is restricted because parabolas have either a minimum value, like this one, where that spot right there is the lowest value, and then it starts going back up again. So the graph goes up forever, but it does not go down forever. It reaches a lowest point, and this one appears to be about -1 or so. But for today, I'm just going to write that the range is restricted. Number two is a line, and lines go forever to the left and right. So again, the domain is all real numbers. It's not restricted. The range is up and down. Actually, lines go up and down forever too, so unless it's a flat line or something. So this range is not restricted. It's all real numbers. Number three, this graph is restricted for the domain because it basically begins here and just moves over to the right, and it actually would keep going forever. This is created from a square root function. The domain is restricted for sure. It's basically all numbers greater than or equal to wherever it starts, which would be 3 here. The range is also restricted because it does not move up forever. Like it's not up here, and it's never going to go up there. It began right here at the y value 0, and then continued sort of diagonal down forever. So I'm going to say that the range is restricted. Number 4 is the graph of the cosine function. And whether you know that or not doesn't matter. The idea here is that this graph is going to squiggle back and forth forever, left and right. So it's all real numbers for the domain. So I'm just going to say it's not restricted. The range, however, is, because if you stare at it long enough, you realize basically the graph gets to a highest point, and then it goes back down to a lowest point, and then back to a highest point, and back to a lowest point. And it's doing that evenly. It's basically like it runs into a wall above it and a wall below it and bounces off that wall. So that's definitely a restricted range. Moving on. Labeling the parts of the parabola, just wanted you to practice some of your vocabulary. So this line here, is what we call the axis of symmetry. It's dividing the parabola exactly in half. It goes through the vertex. So I'm going to write axis of symmetry. Some people really don't like that word axis, so you could say line of symmetry, but usually referred to an axis of symmetry if you were to Google it or something. Let's see here. The second one is pointing at this spot and this spot, and we call those, there's lots of names for those, but primarily they are x-intercepts. What's weird is that they are often not referred to as x-intercepts. So I'm going to go ahead and give you the other synonyms. One of the most common names is the zeros, and another very common word is the roots. And on your final exam this semester, you'll see all 3 of those words. There's actually another one. A lot of times you can think of them as being solutions, and you'll be asked to solve the equation or something, and those are the points you're looking for, probably. Let's see, the next one is the y-intercept. You can see the graph is crossing the y-axis. And finally, we have the vertex down here. And I just wanted to point out that because on this particular graph that's the lowest value, it would be called a minimum. If the graph was turned upside down like an arch, it would be a maximum. But vertex is the correct name. Now, number 6 wants us to go back up there and give the coordinates of the x-intercepts. So here, at this point, from the center, this is 0, 0, so I'd count over 1, 2, 3, 4, apparently -5. So that is the point, -5, 0. And the other point is 1, 0, because it's to the right 1. Now again, this is why we call them zeros, because see how the name is zeros, because the y value is a 0. That's just the way those are always going to be. Now we need to identify the vertex. So that's this point, it is clearly over -2 and down, I believe, -9 or so. So I'm going to say the vertex is -2, -9. And then question 8, would you describe that as a maximum or minimum? I've kind of already answered that. It is a minimum. The lowest that graph goes is -9. That's it for that page. All right. Let's practice a little double distribution. X times x, x squared, x times 4, 4x. 8 times x, 8x, and 8 times 4 is 32. If you've done it in the same order as me, your middle two numbers will combine together. Final answer, x squared plus 4 and 8 make it 12x, and plus 32, and we're done. Let's see, number 10, a little bit trickier here. X minus 3 squared means you've got x minus 3 multiplying itself, like that. Now you can do your double distribution. X times x is x squared. X times -3 is minus 3x. -3 times an x would be another minus 3x. And finally, -3 times -3 is plus 9. The two middle numbers combine together. Be careful on this. As I'm looking at those, I'm thinking about -3 minus 3. So -3 minus 3 is -6 or minus 6x. Careful with those. Minus signs always cause issues. Okay, number 11, basic distributive property. 6 times 5x is 30x. 6 times -4 is negative or minus 24. You're done there. I just asked number 11 to get you in the right frame of mind for questions, the remainder of the questions where it's the reverse distributive property. And what we want to look for is a factor, the greatest common factor of the two numbers, 2 and 10. In other words, what's the biggest number that divides into 2 and the biggest number that divides into 10? I like to show my work like this. So I recognize that I can divide both of those numbers by 2. That's the biggest number I can divide them both by. And that means I can put that on the outside of my parentheses. Remember, I'm reversing the distributive property. And that gives me x, and because 2 divided by 2 is 1, so it just leaves the x, and 10 divided by 2 is 5. So again, if you just stare at that long enough, you realize, oh yeah, 2 times x would be 2x, 2 times 5 would be 10. Done. Number 13, what's the biggest number I can divide those by? Well, again, you might have to stare at them, you might have to play around with the calculator for a little while, but to me, the biggest number that goes into those is the number 6. The more you practice, the better you'll get at this. I will be honest, usually it's a pretty small number. It's either the smallest number, like up here, or it's a number a little bit smaller than that. So I'm going to pull the 6 out like that. 12 divided by 6 is 2. Don't forget your x. And 30 divided by 6 is minus 5. Done. Number 14, what can I divide 8 and 20 by? I think 4. In fact, because it's negative, I'm going to divide by -4. That's just something that math people do. Trust me on that. So I'm going to put the -4 on the outside. Now, careful here. -8 divided by -4 would be positive 2x. And here's the part people mess up. That's -20 divided by -4, which would be positive 5. You should always check your work, make sure it makes sense. -4 times 2 is -8, and furthermore, -4 times positive 5 would be -20, the original problem. So let's see, number 15, it's basically the same numbers. I just wanted to prove a point about what's happening with this negative issue. So I'm still going to do -4 on both of those. -4 comes out. Still get 2x because it's still -8x. But now that this is a plus 20, positive 20 divided by -4 is minus 5. So very similar problems, but their answers are slightly similar. Slightly different. Whatever. Number 16. This one's got more x's than normal, but you've seen us do this in class. I'm going to divide both of those by 2x. That would be the greatest common factor. Now, I know dividing by x's might seem strange to you, but just kind of let it flow. We put that on the outside, and I don't think it's going to be a stretch for you to see that that's going to be just an x in front and a 7 back here. Now again, let's just think of it backwards. 2x times x would be 2x squared for sure. And 2x times 7 would be 14x. So it totally works. One of the most common mistakes is people really want to put an x back here because there was an x back there. But you just got to understand, we just took it away. That's kind of what's happening here. So it's like we're borrowing and putting it out here instead of in there. And we're done with our homework. Good job.